Alright, welcome back to part 2 of our solving our truss right here, step-by-step process. In the last video, we solved for our reaction forces here at, uh, at point A and point C. So we found reaction force RAY and we found reaction force RCY, and we also found a reaction force for RAX, which is actually 0 because we have no forces in the x direction. Okay, so now we're going to move on to question 3, which is going to want us to calculate the member forces for AD and AB. So what we're going to look for next is right here in our truss, we want to calculate the force that is being acted upon this member and this member. All right, so we're going to do that. Now, in their directions, there was, they skipped out a step that we did in the last one. So I'm going to kind of cover this real quick, and I'll just do this in the space. I'm not going to make you work it out, but I'm going to explain how we're going to get it. And what we're going to look for is this actual angle right here. Okay, so they never tell us to solve for this, but in step 3 it says we're going to do this, draw the free body diagram, make sure to include all known and unknown angles and forces, including x, y vector components. Do not include length. And then it tells you to use SOHCAHTOA to express these terms, okay? And then even continuing on, when I look down over here, it's just having us calculate these without ever having us find the actual angle. So kind of sad that they didn't include that step in here, but here we go. So this is what we're going to do. I'm going to leave this right here and kind of explain this. All right. So what we're going to find is this angle. And to find this angle, like we did in the last one, we need to we're going to use tangent. Okay. Now we're going to use our dimensions that we have. So our dimensions that we have is we have the height of our triangle right here. And the height of this is 3, okay, which is this part right here, okay? Then I need the distance to where that height is at. Well, this is 3. So if you look right here, we're basically using this information on the outside, this 3 and this 3, to find this angle. Now, if you look at this, this is a square when we look at this shape, 3 by 3. So if I do that, this exterior angle and this interior angle should be the same. So I'm using this data out here to find this angle, which would be this exact angle here. Okay? If you're going, what? Take geometry. They'll explain it. Okay? All right. So I'm not going to dive into this. Now, to find this, tangent is opposite over adjacent. Okay? That is tangent right there. Okay? They even give it to us in our formula right here. Tangent is opposite over adjacent. So that's what we're going to do. So to find this angle, I'm going to take the inverse, which would be negative, like that's what they mean by inverse, of the opposite over adjacent. So if I take this value, and I'll write this right here for you. So if I take this value and I take the opposite, which would be 3 over 3, and I take the inverse tan of that, what is 3 divided by 3, everybody? 1. And so in your scientific calculator, you take the inverse tangent of 1, you get 45 degrees. Okay? So this angle is 45 degrees. This angle right here, if I come right here, this would be a 90-degree angle that we're going. Okay? All right. Anyway, that's what we need to know right now. Okay? So that's 45 degrees. Okay? Now, kind of back over here, if we go back to this side, angle C is exactly the same thing as this one. We have the same dimensions over here, 1, 2, 3, 1, 2, 3. So we can safely say that that angle is also 45 degrees. Okay? So there we go. We're going to use that angle. We need to use that measurement of our angle. All right? I hope that helps. Okay, now in 3, they want us to draw the free body diagram for joint A. So right here I want to draw the free body diagram for joint A, and that's what we're going to do. That's going to help us find those 2 points. So basically I'm going to draw my little line. Okay, it goes up 1, 2, 3. So we're going to do this right here. Hang on, Mr. Womack's getting his ruler out. Going up this direction. So this is point D. This is A. All right. This is going to go out to B, which is down this direction over here. Okay. So this is what I'm solving for right here. These are the 2 things that I'm solving for. And we just found this angle. So 45 degrees. That's what I know. Okay. Now when I'm drawing my free body diagram, I need to include the information that I have. So this is RAY, and we solved for that last time, and we came up with 979 pounds. Okay. This right here is RAX, and that one was 0. Okay. Right? So now I'm going to take this information that I have, and I'm going to solve for these parts over here. Okay? So here we go. First thing it wants me to solve for is angle D. Okay? So I have angle D. Now I'm going to extend this up a little bit because this, I had a couple of questions on this already from people. All right? This 975 pounds continues up this side. So there's this 975 is over here as well. Okay? I have this going this way. This is my ADX up here. Okay? So I have these vector components. This is RDY at this side because this is coming down right here. Okay? Hopefully you can kind of see that. So now to solve this, I'm going to use my equation. Sine of my, sine theta equals opposite over hypotenuse. Okay? So there we go. So now I'm going to plug in my information that I have. Okay? So at this point, we're going to plug in, and I'm going to have sine. Now that we've solved this out, I have sine of 45, okay, right here, equals ADX over ADY, because these are my these two pieces together is what's going to equal this. Remember, we took those vector forces and we had an x component and a y component, so that's what we did. So ADX will equal ADY times the sine of 45. Okay? Are you with me on that part so far? Hopefully you are with me on that part so far. All right. Are we good? Hopefully you're not like too confused at this point. All right. So all I'm doing is writing this in here. Okay. Now to find ADY. Well, ADY is going to be this line. Okay. So this line is going to end up being cosine. All right. So cosine theta equals, that is going to be adjacent over hypotenuse. let's plug in what we have. So I take the cosine of my angle, which is 45 degrees, equals my adjacent angle is ADY, and my hypotenuse is going to be AD. Okay? Oops, did I do ADY up here? This should have been AD. That's my bad. Okay? All right. My bad. Okay, there we go. So I messed up here. All right. All right, how are we doing? Sorry, sometimes I don't look at the camera, and if this gets off, I noticed in my last video some of the things were missing. Okay. All right, so now let's isolate. We're looking for ADY, so I need that all by itself. So ADY, if I get ADY by itself, then I would just multiply ADX out over here. So cosine of 45 degrees times AD is what equals ADY. Okay? All right? So there we go. Moving on. So this is all I'm doing. Right now, I have done no calculations. I'm putting formulas in and I'm simply isolating stuff out. Okay? That's all we're doing right at this point. Okay? We'll come back and we're going to use these formulas in a moment. Now let's list all of our known and unknown forces that we have. Well, here's what I do know. Okay? In my x direction, I have 0. So here we go. I'll put this up. I have 0. Okay? In my x direction, I am also looking, going in the x direction, I'm looking for ADX, which is this part that's going to here. Okay? So I'm looking for ADX. All right? So or line segment actually, not ADX. AB is going in that force. I'm looking for that. Okay? And then the other force that I'm going to look for is this one that we looked up for up here, is that ADX, which is, if I take the vector force here, that's my ADX. Sorry, I was just getting those mixed up. ADX, which we said equals AD times the sine of 45 degrees. Okay? Right? Now forces in the y direction. Well, my y direction forces, I have this one right here. I have 975 pounds going in that direction. Okay? And then I have AD cosine of 45, which is the one that we solved for right here. All right? So we were calculating our ADY. So if you're sitting here going, where did these come from? Where did ADY come from, Mr. Womack? All right. Again, this is our vector force that we have right here. So this is our vector. This is composed of a y force that's going this direction and an x force going this direction. That's what causes this to go up and to the right. Okay? So we have to have a y force going up and an x force going to the right like that. Okay? So that's what we're using to find this. All right. Now, we have those points labeled. Now we're going to use our static equilibrium, which is part D right here. It says use static equilibrium equations to solve for AD and AB. So here we go. This is where the rubber hits the road. All right. So Static equilibrium equations. We're going to solve for our moments that we have, or sorry, solve for our forces that we have. So I'm looking for my y forces. So I'm going to be using all my y information. Okay, so here's what I have. Remember, this is summing them together. So I have 975. This was my y force. Okay, plus, and in my y direction, I have AD cosine of 45. All right? We good with that so far? Okay. Now we're asking to simplify this. So to simplify this, we're going to end up with what we need to do is get AD all by itself. Well, to do that, get AD all by itself, I'm going to subtract 95. So if I take AD cosine of 45 equals negative 975. Okay? Now my next step is how do I, over here, I have to get cosine of 45 out of this equation. So I'm going to divide. So that leaves me with AD equals negative 975 divided by the cosine of 45 degrees. All right, so here you go. You have your first question coming up. You need to plug this into your calculator and come up with the question and come up with the answer. All right, good. All right, now hopefully you came up with negative 100 or 1,378.9 pounds. Okay, so that is AD. All right, that is the force that's in there. Now it's negative. So what is that going to tell us about our force? Is it in tension or compression? We'll come back to that. All right, but let you leave that. So now we're going to solve for our AB forces. So we're going to do the same thing. Okay, so our equation is going to be sum all of our forces in the x direction. So let's plug in what values we have. Okay, going back for our values that we have up here, I have 0. Okay, I have AB. Okay, and I have this right here, which would be AD times the sine of 45 degrees. Okay? You're good? Now we're going to simplify it. So here we go. What do I do first? Well, first I have to get 0 over here. Oh, wait a minute. So there we go. All right. So we have this AD, which I came up with this particular unit right here. I'm going to have substitute my value in here for AD. Let me go ahead and erase that and put that in here. All right, I know they tell us to do it in another step, but I'm going to do it here. Negative 1,378.9 times the sine of 45. Now let's simplify this, okay? So I've got to, if I just do this and I leave, subtract 0 over to the other side, so get rid of 0 because that really doesn't do anything, then I'm going to subtract and have AB equals, all right, and since I have negative, that's going to be, I've got to add 1378.9 times the sine of 45. Okay? So there we go. We have that. That's what should go in here. I'm going to cross this one out because I kind of skipped that step. So now what you need to do is you need to plug this into your calculator and solve it out. Okay? So you'll do 13.78 or 1,378 and 9/10 times the sine of 45 degrees. Do that. It's going to pop up on your screen. Answer it. And you should have come up with 975 pounds. Okay? All right. So now we're going to update the joint free body diagram with our calculated forces. So let's go back over here. Okay? So here's what we have so far. Okay? So AD we calculated, so this one right here is negative 1,378.9. Now because that's negative is going to be in compression. So I'm going to put a C right there for compression. Okay? AB is going to be 975 pounds. So I'm going to put 975 pounds right here. All right? So that's what it would like us to do at that point. All right? So I'll put a positive, and I might even put like a little T right there for tension. Okay. So there we go. That is, this should be question number 3 that we just worked through. Okay? So there's the video for question 3, or step 3, however we want to look at that. And then the next video will be step 4. Okay? All right. Good luck, and I'll see you in step 4.